So this is density. We have learned about metrics, we've learned how to measure, we have learned how to read measuring instruments. So now we're ready to do something with it and start really studying matter and different properties of matter now that we have the tools to do it. So let's review a little bit. So mass is the amount of, great job, matter in an object. So possible units for mass could be, boy, you're really smart. That's right again. Anything that ends in gram, gram, milligram, centigram, hectogram, decagram, kilogram, anything that ends in gram. And volume is the amount of, right again, space that matter occupies. And possible units for volume could be, remember, for a solid object, it could be centimeters cubed, it could be milliliters, it could be kilometers cubed, liters, kiloliters, etc. And remember, 1 milliliter is equal to 1 centimeter cubed. So you should be at the top of your notes right now and have pretty much the first couple of things filled out. So now we're ready to look at how do mass and volume relate to each other. All right, so let's make a model of mass and volume in a football bleacher scenario. Well, how can we increase how tightly packed the bleachers are? So we've got some people, and let's see here. Well, first of all, we could just add more people, and that makes it more tightly packed, or we could make all of the people just stay in one half of the bleachers. That also makes it more tightly packed. So if we were to put this into a mass and volume scenario, we could say that the mass, or the matter or stuff, will be represented by the fans. So that's the blank that is under the boxes. And in the boxes you can fill in circles for the little heads of the people. So you could start off with the first box kind of having, what are there, 8, 10 circles in it, and then you could put a bunch of circles in the add more box, and then you could put, that 10 circles in only half of that last box to help you fill in the notes. So now we're going to look at, well, what is the definition of density? Yes, all of this is related to density. Okay, oh, forgot, here we go. The volume or space for the matter or stuff will be represented by the bleachers. So that is that second line under the little squares. The volume is represented by the bleachers. Okay, so now then, so we've got mass and we have volume. We have people per bleachers, or fans per bleachers. So let's look. Well, the definition of density is the measurement of mass contained within a specific volume. Okay, and this is one of your vocabulary terms. I know that for sure. So is mass and volume, by the way. Okay, and that is called density. So in that blank, where it says the measurement of mass contained within a specific volume is called blank, you need to put density there. So since it's mass per volume, that means that our units are just a mass unit over a volume unit. So that could be grams per centimeter cubed, mass unit over volume unit, grams per milliliter, milligrams per kilometer cubed, kilograms per liter, milligrams per kiloliter, etc. Okay? Basically, again, any unit of mass per any unit of volume. We even use density in social studies. So let's look at this picture. This is not on your notes, by the way, but what density units are being used for this map? So the stuff would be, it looks like inhabit, which means inhabitants or people who live there, per square mile. So that's our space. So people per square mile. And as we get into the darker colors, we get more people per square mile. So if you want to live somewhere where there aren't many people at all, I think I would probably live in the central west because it just doesn't look like there's a whole lot of people there. And again, inhabitants per square mile is the same as mass per volume. So density can also be thought of as how tightly packed the atoms or molecules of a substance are. And we're going to be talking about atoms and molecules. And atoms are the smallest basic unit of matter, and it's what makes everything. So which do you think is more dense, a rubber bouncy ball or a solid steel ball bearing? That's a tricky one. Well, it's definitely that solid steel ball bearing, okay? So if we change either the mass or the volume, we can cause a change in density. Now these two have roughly the same volume, but probably very different masses. And the same with the ping pong ball and the golf ball. They have roughly the same volume, but they have very different masses and therefore have very different densities. And this is what you need to fill in at the bottom of that page. So now then, I'm going to stop there for just a minute. If I can find. So now, looking at the next page of notes, if you took a break there for a minute, we're going to look at calculating density. So we're just going to review that last page again. And it says, what is density? Well, remember, density is the measurement of mass contained within a specific volume. And how do we calculate it? Well, the formula for density is mass over volume. Mass divided by, which means mass divided by volume. So I need to fill this in kind of in that second line, and then this would be in the first line next to that review question. So it says, what is the density of an object that has a mass of 50 grams and a volume of 25 milliliters? So I just simply take the mass and divide it by the volume. So 50 divided by 25 is equal to 2, and I just put those units in after the 2. It's 2 grams per milliliter. So that would go after that example problem. You can fill this in and refer back to it for help for other density problems that you're probably going to do in class. Okay, so here's something. What is the formula triangle and how do we use it? We will be using the formula triangle off and on all year long. And it is a very handy way to put formulas with 3 variables in the equation, which a lot of them have that. So since there are only 3 variables in the density equation, we can use the formula triangle to solve for any of the variables. Let me show you how it works. So we have this M represents mass, the D represents density, and the V represents volume. So whatever it is we're looking for, we just simply cover up the variable we're trying to solve for, and we'll see the formula that we need. So for example, if I am trying to solve for volume, I would cover up the V, and my formula would be mass divided by density. If I wanted to find density, I would cover up the D, and I would see the formula mass divided by volume. If I wanted to find the mass, I would cover up the M, and I would see density times volume. So there you go, pretty simple to use. So this is our dividing line, and then we multiply these two together. So for example, a boomerang has a density of 0.5 grams per centimeter cubed and a mass of 15 grams. And I want to know the volume this time. They gave me the density. So I would plug in my density as 0.5 grams per centimeter cubed and plug in my mass of 15. So volume again, cover it up, it's mass divided by density. So it's going to be 15 divided by zero point 0.5. And that gives me a volume of 30, and it looks like our grams are going to cancel out and we'll end up with centimeters cubed. So fantastic. So why do those units cancel out? How does that end up happening that way? Well, units work the same way that numbers do in math. So in other words, if I had 2 divided by 2 over 3, it would be the same as 2 times the reciprocal of 2 over 3, which would be 3 over 2. So my 2's would cancel out and I would be left with 3. Same thing, 3 divided by 3 over 5 would be just 5. So grams divided by grams per centimeter cubed would be just centimeters cubed. Voila! So we can pause here for a moment and get ready for the last page of the calculating density notes. Now this is where density and now we're on the third page where it says graphing density at the top. So this is where density and really properties of matter that kind of comes together. So we see how we can use the skill of measuring and knowing what density is to help us identify substances, okay, which is going to lead us into chemistry. All right, so we're going to look at a substance. Actually, it's an element called aluminum, okay? And since density is a ratio between two measurements, which would be mass and volume, okay, think mass over volume, x over y, or difference of the difference of the y's over the difference of the x's can give us a slope. We can plot it on a graph. So here we go. If we put mass on our y-axis, okay, and volume on our x, then we might be able to see a pattern here for substances that are the same throughout. So here we go. When we plot the mass and volume for aluminum, give you a minute to fill that in. So up by tens on the y-axis, and for every 2 blocks it looks like we're going, I think you can just go over on every block. You can just hit 5, 10, 15, 20, 25 and shrink yours up a little bit. Yours is a little shorter on your notes, but we'll still see the same pattern. Once we plot all of our dots, 5 and 13.5, over 10 up 27, over 15 up 40.5, over 20 up 54, over 30 up 81, over 40 up 108, and over 50 and up 135. Can you see the pattern? I hope so. If not, I think something's wrong. So anyway, here we go. We can see that a straight line was formed, that all of those dots fall on the same slope. That's amazing, and that's something true with any type of matter that's the same throughout. It has the same density. It doesn't matter how big. If you notice, we go from 13.5 grams to 135. It doesn't matter how big or small it is. Any size piece of aluminum is going to fall on this slope because it all has the same density. It all has the same mass over volume. So it's pretty amazing. It has the same slope, so you can fill that in. on your notes right under the graph. And this is a really, really super important concept. And actually, this is the concept that your density performance assessment will be based on. So it's really important that you grab onto this and you understand it. Okay? So in other words, I could have a piece of aluminum that is 300 grams, and it is going to fall somewhere on a line way, way out there, but it's going to fall on this same line, and it's going to have a corresponding volume that's going to make it have the same density or same slope. Okay, so it shows that the density for aluminum is a constant, meaning that it's the same no matter what the mass or volume. And this is true for all types of matter. Okay, so you can put that on your notes. So, if you just heard a dog barking, that was my dog, and he was upset because he heard my sons outside. So things happen, real life happens. So here we go. Using the aluminum again, we can see that no matter what we put over what on that information, let's go back over here, we are going to end up with a density of 2.7, whether it's actually 27 over 10 or 135 over 50. It's going to end up being, and let me flip back to the correct slide again, it is going to end up being 2.7 grams per centimeter cubed. And we can see here that that is the constant for the density of aluminum. And all these other substances have the same density no matter how much. Water, same way. There we go. For example, the density of water is always 1.00 grams per milliliter. So this is a big, big point. Okay? All right, so on your notes you have this is actually true for all types of matter. For example, the density of water is always 1.00 grams per milliliter. So you're going to put that on that little line next to always, but on the big line with the 3 exclamation points, you're going to write this: density is a property of matter, because that is a huge concept that you need to understand and put in your brain. One last thing on density, an important point about density in liquids. So if an object is more dense than the liquid it is in, it will sink. Okay? So if I put a rock in a glass of water, it's going to sink because it's more dense. If an object is less dense than the liquid it is in, it will float. Okay? So if I put a piece of styrofoam in a glass of water, styrofoam's a lot less dense than water, it's going to float. And that is the end of the notes. Thank you for listening and have a fantastic day.